Hello ladies and gentlemen, welcome to my video. This is today's questions. Put aside the difficulties, it is definitely interesting questions. To my knowledge, there are at least 3 methods of solution. Number 1, using complex analysis. Number 2, using expansion of the series. Both are pretty tough. So therefore, we go for the third option, which is using inverting variable strategy combined with Euler formulas. Yesterday video, we solved a question that part of it is similar to the today questions. Therefore, we will not repeat the derivation of the inverting variable strategy. Check out the description section for the link of the yesterday video. The equation that we derived yesterday definitely suitable for today's questions. We can rewrite the question Q equals to integral 0 to infinity natural log x divided by x squared plus I squared dx, where I is imaginary number which is square root of -1. From the equation that we derive from the inverting variable strategy, it is equals to pi multiply natural log I divided by 2i. For the natural log I, we rewrite as natural log square root of -1. Using the rules of natural log, we can rewrite it become pi multiply natural log -1 divided by 4i. Next, we look at the popular Euler formulas. E power I theta equals to cosine theta plus I sine theta. In the case that theta equals to pi, so we have e power I pi equals to cosine pi plus I sine pi. So that gives us e power I pi equals to -1. Let's put this into previous equation, which means we have q equals to pi multiply natural log e power I pi, and then the whole thing divided by 4i. That brings us to the conclusion of this video. The final answer of this question is equals to pi squared divided by 4. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video in your social media. See you tomorrow for more video. Bye bye.